Now our next question is the velocity of particle in SHM at position x and y, x and x2 are v1 and v2. So two velocities are given at the instant. The displacements are x1 and x2. What will be the time period and amplitude? So we have to use a general equation of velocity. The general equation of velocity of harmonic oscillator is omega under root a square minus x square. Then we take the square of the number and that will become omega square into a square minus x square. Now this is the general expression of square of the velocity. So we will form two equations, one with v1 square and other with v2 square. So we will write two equations in terms of v1 square and v2 square. Then we take the difference of the two values, that is v1 square minus v2 square, that is from equation number 1 and 2, and our net expression will become omega square into x2 square minus x1 square. Now from this expression we have to get the value of omega. So what exactly we have done? That is omega square is equal to v1 square minus v2 square divided by x2 square minus x1 square. So in order to find omega, we will take square root and the net function will become omega is equal to under root v1 square minus v2 square divided by x2 square minus x1 square. Now we have to find the time period. We know that time period is taken as 2 pi by omega. So 2 pi and then we write the value of omega. So 2 pi over omega. So the expression will become t is equal to 2 pi under root x2 square minus x1 square divided by v1 square minus v2 square. So we have computed time period as 2 pi by omega and from that we got this function, time period. Now slightly more elaborately if we proceed, we have written one of the equation as v square equals to omega square into a square minus x square. If we are interested to find the kinetic energy of the harmonic oscillator, in this equation, we multiply both sides by half m. So if we multiply by half m, the function will become to the left side half mv square and to the right side half m omega square into a square minus x square. Then we can estimate the kinetic energy at mean position and at extreme position. Wherever we use the term extreme, the displacement is maximum, that is x can be replaced by a, and at the mean position we find that displacement is minimum. So x can be replaced by 0 and we can come to the various conclusions. So now here we are dividing first equation by second equation, that is v1 square over v2 square, and that will become a square minus x1 square over a square minus x2 square, where a is same for both the SHM. Now we have cross multiplied the two numbers, and after cross multiplying we made the subject of equation, that is a, and a is calculated as v1 square x2 square minus v2 square x1 square divided by v1 square minus v2 square. So in order to find v maximum, that is equal to a omega. So for a we will compute the upper value and for omega we will write omega as it is. So the maximum velocity at the mean position is a omega, and for a we will compute the value and that will be the maximum velocity. Now our next question is, which of the following functions represent SHM? Now there are four functions given, one in terms of square and other the plane functions like sine 2 omega t, sine omega t plus 2 cos omega t, sine omega t plus cos 2 omega t. We have to make our decision that which of these functions are indicating SHM. At least just by observation, the first function is not indicating SHM, being it is a square function. Now how to solve it out will come to our conclusion, as I have explained you, that sine square omega t is not representing the equation of SHM. So how to describe the first equation? A motion will be SHM if acceleration is proportional to displacement. Negative sign always means that A and Y are in the opposite directions. Now our equation is y is equal to sine square omega t. Normally this is not the rule. The rule is sine omega t is okay, but now it is sine square omega t. This what we wanted to prove, whether this function is a function of SHM or not. Now when we write sine square omega t, we first of all take the derivative of displacement. So we have taken the derivative of y with respect to time. It is dy over dt. And to the right side, we'll take the derivative of sine square omega t. So derivative of sine square omega t will be 2 sine omega t into, it is 2 sine omega t cos omega t into derivative of omega t, that is omega. So again we are using the trigonometrical formula, and that function is found to be sine 2 omega t. Now when we write sine 2 omega t, it means we are saying sine 2a. Sine 2a means 2 sine a cos a. That is what we have written in the next step. So we have taken the acceleration. That is double derivative of displacement is called acceleration. So we have taken one derivative, that is the velocity. Now we are taking the derivative of velocity. That is, we are taking the derivative of sine 2 omega t. The derivative of sine omega 2 omega t is cos 2 omega t into derivative of 2 omega t, and the whole thing will become 2 omega cos 2 omega t. So in order to understand all these steps, it's very essential to go through with the derivatives. So normally in the whole of the SHM, we are going to use the derivatives of the sine functions and the cosine functions, and we will use the trigonometrical formulas like sine 2a and cos 2a, along with sine a plus b and sine a minus b, cos a plus b and cos a minus b. So in order to understand these questions, it is very essential to understand the basics of trigonometry. Now, our function is sine square omega t. It is not a function of SHM, because in the last step, what exactly we got? In the last two steps, in velocity we got sine 2 omega t, and in acceleration we got 2 omega cos 2 omega t, and the given function was a square function, so it means that the square function is not a function of SHM. That is what proved for the first equation. Now we proceed with the second equation. We have again taken y is equal to sine 2 omega t, and we have again taken the derivative, that is dy over dt. We will read it as derivative of y with respect to time, and that is equal to velocity. So we are taking derivative of sine 2 omega t, and the derivative of sine is cosine of the function. So we have written the derivative of y, and derivative of y is 2 omega cos 2 omega t. So this is the value of velocity, and that's a plane function. And for acceleration, again we have taken the derivative of velocity, or we have taken double derivative of displacement, and that is found to be minus 4 omega square sine 2 omega t, and wherever we write sine 2 omega t, that sine 2 omega t will be replaced by y, and our net function will become minus 4 omega square y. So y is equal to sine 2 omega t represents SHM, because the function comes in terms of omega square y. That is the differential equation of SHM. Now we come to the third function, that is y is equal to sine omega t plus 2 cos omega t. Now we are finding in this question that displacement is given in terms of the addition of sine and cosine, but the displacement must be necessarily a function of sine or a function of cosine. So what we have to do, we have to transform this function to a single function that is in terms of sine or in terms of cosine. So what we are doing, first of all, we have taken the derivative of y. So derivative of y we have calculated, that is, we have taken the derivative of sine omega t and the derivative of 2 cos omega t. After getting this value, we have to calculate acceleration, and that is the rate of change of velocity, that is dv over dt. So for the above equation, we have again taken the derivative, and when we will just take out omega square common, the net expression will become minus omega square into sine omega t plus 2 cos omega t, and that is given formally the very first line, that is y is equal to sine omega t plus 2 cos omega t. So our net function will become minus omega square y. Again, acceleration is calculated as minus omega square y, and that is what the important characterization of the SHM. Therefore, the third function is a function of SHM. This is also proved. Now we come towards the fourth equation. The fourth equation is also in terms of sine and cosine. The solution is similar to that of third one. First of all, we have to take derivative of y with respect to t. Then we will calculate omega cos omega t minus 2 omega sine 2 omega t. Then we take the second derivative of displacement. Then we take out the commons, and we don't find that we have come to the initial function. So the given equation can be oscillatory, but it is not SHM.